In the grand story of scientific breakthroughs, we often celebrate the big names, the Einsteins and the Curies. But what about the quiet pioneers, the ones whose brilliant insights get lost in the footnotes of history? Today, we're pulling one of those names out of the shadows, Domenico Pacini, the man who arguably discovered cosmic rays first, but never got the Nobel Prize for it. Our story starts in the early 1900s. Physicists were baffled by a strange phenomenon. An instrument called an electroscope, even when perfectly sealed and insulated, would slowly lose its electrical charge. It was as if it was being zapped by invisible, highly penetrating rays. The leading theory? This mysterious radiation was coming from radioactive elements in the Earth's crust. It made sense, right? The Earth is full of radioactive stuff. But one young Italian physicist, Domenico Pacini, wasn't so sure. Born near Rome in 1878, Pacini was a meticulous and creative researcher. Working at the Italian Meteorological Office, he was fascinated by atmospheric electricity. He thought, if this radiation really comes from the ground, its intensity should change depending on where you are. So he began a series of clever experiments. He took his sensitive electroscopes up mountains and out over lakes, measuring this background radiation everywhere he went. He was gathering clues, piece by piece, building a case against the established theory. He suspected the answer wasn't beneath our feet, but somewhere else entirely. His most brilliant and decisive experiment came in the summer of 1911. Pacini took his equipment, not up into the air, but down into the water. He chartered a boat and sailed out onto the Ligurian Sea. First, he measured the radiation at the surface. Then, he did something extraordinary. He lowered his specially designed electroscope 3 meters deep into the sea. His logic was simple but powerful. Water is an excellent shield against radiation. If the rays were coming from the seabed, the 3 meters of water above his instrument shouldn't make much of a difference. But if they were coming from above, from the sky, the water would block them. And what did he find? Exactly that. The radiation level 3 meters underwater was significantly lower than at the surface. The water was acting as a shield, proving that a large part of this penetrating radiation had to be coming from outside our terrestrial environment. It was coming from above. In February 1912, he published his results, stating clearly that there exists a notable cause of ionization in the atmosphere, independent of the direct action of radioactive substances in the crust. He had found the first solid evidence of extraterrestrial radiation. Now you might be thinking, I've heard of the discovery of cosmic rays, but the name I know is Victor Hess. And you'd be right. Around the same time, the Austrian physicist Victor Hess was taking a different approach. He was going up, not down. Hess conducted a series of daring balloon flights, carrying electroscopes to altitudes of over 5 kilometers. He found that the radiation didn't decrease with height, as you'd expect if it came from the Earth. Instead, it increased dramatically. The higher he went, the stronger the signal. This confirmed that the radiation was indeed coming from outer space. Hess's high-altitude balloon flights were dramatic and compelling. They captured the scientific community's imagination. In 1936, Victor Hess was awarded the Nobel Prize in Physics for his discovery of what Robert Millikan would later name cosmic rays. But where was Domenico Pacini in all of this? His name was nowhere to be found on the Nobel certificate. This was a source of deep bitterness for Pacini. He believed, and historical letters support this, that Hess was well aware of his 1912 publication. Pacini's work provided the crucial first piece of the puzzle. His underwater experiment had elegantly ruled out the terrestrial origin theory, paving the way for Hess's high-altitude confirmation. Yet, his contribution was overlooked. Pacini felt that his foundational discovery had been deliberately ignored. He had provided the why not from Earth, and Hess provided the why from space. Both were essential parts of the same discovery. It's a classic tale in the history of science. Sometimes it's not just about being right. It's about being heard. Hess's balloon flights were more direct and perhaps more spectacular, making for a better story. Pacini's methodical submarine experiments, while scientifically just as conclusive, didn't have the same headline-grabbing appeal. He was the quiet foundation upon which a celebrated discovery was built. Despite the profound disappointment, Pacini continued his scientific work. He became a respected professor of experimental physics and continued his research until his death in 1934, just 2 years before the Nobel Prize was awarded. He never saw the official recognition he so rightly deserved. So why are we telling this story today? Because science isn't just a series of eureka moments by lone geniuses. It's a collaborative, often messy, human endeavor. It's built by people like Domenico Pacini, who asked the right questions, devised clever experiments, and had the courage to challenge the consensus. His experiment in the deep, silent waters of the Ligurian Sea was a moment of pure scientific insight. It was the first time anyone had looked for the origin of these cosmic messengers, not in the stars, but in the sea, and found the answer. Today, the study of cosmic rays is a huge field. We build massive detectors deep underground and under the ice of Antarctica. Modern versions of Pacini's underwater experiment to study neutrinos and other elusive particles. These incredible endeavors all follow the same basic principle that Pacini demonstrated over a century ago, using the Earth itself as a shield to filter out noise and isolate signals from the cosmos. Domenico Pacini's story is a reminder that for every celebrated discoverer, there are often unsung heroes who laid the groundwork. He may not have a Nobel Prize to his name, but his legacy lives on in the very methods we use to explore the universe's biggest mysteries. He was a true pioneer, a man who saw what others missed and had the genius to prove it. Thanks for joining us on this journey into a forgotten chapter of scientific history.